One of the tools for controlling quality is the control chart. This is the only quality tool that takes into account the factor of time. You can use a control chart to evaluate an attribute of a product or service, allowing you to identify trends that could suggest the process is moving out of control. An upper control limit and lower control limit are established based on stakeholder requirements and provide a range of tolerance for acceptable samples. There are two situations where a process is considered to be out of control. If one sample, just a single one, falls above the upper control limit or below the lower control limit, the process is out of control. The other situation is when a series of 7 consecutive samples fall on one side of the mean, either between the mean and the upper control limit or between the mean and the lower control limit. This is called the rule of 7. If either of these situations occurs, you must stop the process and determine the cause. Usually, a root cause analysis will be performed. You may be wondering, why does it matter if 7 samples in a row fall on one side of the mean? Isn't that still within the acceptable tolerances? And what is the significance of the number 7? The statistical likelihood of 7 samples in a row falling on one side of the mean is quite low, and it may be an indicator that the process is trending out of control. Let's explore an example. If I flip a quarter, what is the chance that it will land on heads? If you'd like more time to think about your answer, just pause the video and resume when you're ready. If you said 1/2 or 50%, that is correct. Now, what is the likelihood that if I flip 7 quarters, every one of them will land on heads? Do you know the formula for this? You may pause the video at any time to determine the answer and then resume the video when you're ready to hear the correct answer. If you said the answer is 1/2 to the power of 7, or 1/2 times itself 6 more times, you are correct. If you calculate the likelihood, it is actually 0.0078. There is only about a 7 in 1,000 chance that you would flip 7 quarters in a row and they would all land on heads. We should probably be suspicious of this outcome and do some investigating. Now, we know there are two situations where a process is considered to be out of control. One sample that falls above the upper control limit or below the lower control limit, or the rule of 7, a series of 7 consecutive samples falling on one side of the mean, either between the mean and the upper control limit or between the mean and the lower control limit. We are going to perform a few control chart exercises to test our ability to identify processes that are out of control. In this example, we have an upper control limit of 11 and a lower control limit of 3. We have 4 series of samples that represent control chart data. Can you identify which series is out of control? Feel free to pause the video at any time and resume when you're ready. If you need a little help, you might consider drawing a control chart with the upper control limits and lower control limits. The mean is simply the average of the two, so in this case, the upper control limit is 11, the lower control limit is 3, and the mean is the average of these, or 7. You can plot each of the 4 control chart series to help determine if they meet the criteria of being out of control. In this series, the series B with data points 4, 4, 6, 6, 3, 5, 4, 5, and 11 is out of control. Did you solve this one? The reason this series is out of control is because it meets the rule of 7. In fact, in this series, there are actually 8 data points in a row that fall between the mean and the lower control limit. This process is trending out of control. Let's try another control chart exercise. In this example, we have an upper control limit of 50 and a lower control limit of 12. Can you identify which of the 4 series is out of control? If you'd like more time to think about your answer, just pause the video and resume when you're ready. Perhaps you didn't even have to draw a control chart for this one. Why not? If you took a moment to review all of the data points, you may have identified that data point 11 falls below the lower control limit, and therefore Series C is out of control. Remember, just a single data point that falls outside of the control limits means that the process is out of control and you must determine the cause. In summary, the control chart is a quality tool that takes into account the factor of time. You can use a control chart to evaluate a product or service, identify trends, and determine if a process is out of control.